with window type CTs. This would include your JAKO, JABO, JADO, and CLC. The leads we'll use for this are your 50 amp multi-pin current cable, a drive cable. This cable has two B and C ends on it, red and white. They're labeled drive and return. We'll also use the direct current cables shown here on the left. These have a B and C connector on one end and an alligator clip on the other. They are labeled drive and return. We'll start our hookups here with your normal 3-way current splitter. And to that we'll add one of our flex probes, just like we normally do. Just pick one of your probes and we'll plug it in on the red current lead. Next up, let's get the 50 amp multi-pin current cable out. And then your two direct current cables. The Powermaster uses the B-phase current leads to measure the secondary output of the CT. And in just a minute, we'll use the red current leads to drive the primary. And we'll just be sure we match our plugs, drive and return. Connect your alligator clips to your secondary terminals. The white clip goes to the polarity mark. Make sure the CT is unshorted and the clips aren't touching the shorting bar. Now get your drive cable, and at first we're only going to hook up the lead labeled drive. Now you'll have to think of this just like you would on the job. Your current is being driven. It's going to come from the source on the polarity side. So you'll actually insert the return lead in first, and you can loop it through once or as many as 5 times. Once you've selected your turns ratio for the drive cable, connect it to the A-phase current lead labeled return. Now we'll grab that flex probe that we hooked up in the beginning, keeping in mind the current flow directional arrows. Loop the flex probe around the turns of the drive cable. So this may be where you ask yourself, how many turns should I use? And the answer is easy. It depends. Let's start by looking at a 200 to 5 CT. We'll always see the best test results if we stay within a CT's window of accuracy. And for a 200 amp CT, that would be roughly between 20 and 200 amps. We could accomplish the minimum with 1 turn and only 20 amps. But we'll get better test if we pick a turns ratio and amp combination that will result in roughly the nameplate current. As we move into the really large CTs, say a 2000 to 5 for example, we're kind of approaching an upper limit of our test set. Again, we're going to see the best results in that window of accuracy, but in this case, we're not going to be able to get to the 2000 amps. About the max you can get is 250 amps, but that should still be able to test 99% of our CTs. Keep in mind the new extended range CTs have a wider window, so the lower end is even better. And lastly, we'll hook up our voltage cables. We'll just piggyback them onto our AC adapter box. Now let's look at bar type CTs. This test will work with any windowless CT, and it's basically the same test, we're just using a different drive cable. They're shown here on the bottom right, and the only difference is they have alligator clips instead of BNC connectors. Your leads will hook up the same as the Windows CT test. There's just a different drive cable. We're still observing the same polarity. The drive cable goes on the polarity side. It can be a little awkward to hook up your flexible current probe. You can double wrap it, or you can even put it around the drive cable. And as always, look at your current flow arrows. We're in the shop today, but I have simulated a CT meter with a CT on A phase. In the field, most of our connections will be in the meter base. We'll start with the voltage leads. Put the white neutral on the neutral connection and the red voltage lead on A phase. Alright, open the current return switch on the phase you're working on. Our direct current cables will now land in the meter base. White on the top, yellow on the bottom. Electrically, this matches the polarity we had on our benchtop test. To break the connection in the test switch, we'll insert an isolation stick. The drive cable is installed just as before, anywhere from 1 to about 5 turns. Depending on the conditions at your site, it may be safer just to use 1 turn. And the last lead we'll hook up is a flexible current probe. Check your current flow arrows on the probe and ensure that the probe goes around the customer's wire and the drive cable turns. And that's about it for cables and connections. Up next, the test set. First up, let's select our site. Then we'll click Edit Site to make sure we have the right CT selected. We'll click Next Page, go to our CTs. Pick the right CT from the list. And hit Save and Exit. We'll press Select to load that site into the memory. Now we're going to pick number 4, Instrument Transformer Testing, and number 2 here, CT Boost Testing. When this page comes up, most of your data is going to be imported from your site. You can select double wrap, make sure your burden and your drive current's where you want it. You can change these values. Make sure you have the right turns ratio. We'll press Start Test. Next. And start test for the second time. And press Start Test for the third time. And our first attempt failed. You need to look at your numbers, decide why. And in this case, it's because my flexible current probe had fell over and was no longer at 90 degrees to the conductor. So we'll go back through it, hit retest, start again. And start once more. What's that, 5 or 6 now? And again, the same error, just because we're not driving very much current. But by holding the probe straight, the test passed. Now keep in mind, all of that was just for a phase. If we want to go back and test the other phases, we'll have to hit previous, start all over, go back to CT boost testing, remove all of your leads and connections, put them on B phase, and you press F3 to load the CT data for B phase, and proceed with testing.